This first video is about the probability of disjoint events, and we'll talk about what exactly we mean by disjoint. I want to use a really common scenario that we think about to think about probability, which is rolling a six-sided die. We're used to saying that the probability of rolling a 3 is 1 in 6. And in order to set us up for what we're going to talk about later, I want to think about that in the following way. If I were to roll this die a whole lot of times, then the number of 3s would be about 1/6 of the total. So if I imagine I roll the dice and every time I roll it I write down what I get, then if I separate out the 1s, the 2s, the 3s, and so on, the 3s should take up about 1/6 of the trials. So what if I ask you about the probability of rolling a number that's less than 3? Well, if I look at all of my trials, the numbers that are less than 3 are 1 and 2, and each of them takes out about 1/6 of the total. So altogether, this takes up about 1/3 of the total. So the way that I figured out the probability of taking one of two events is, I said the probability of rolling a 1 or rolling a 2 is the sum of those probabilities. The probability of rolling a 1 plus the probability of rolling a 2. And the reason that's going to work is that if I want to know when I roll a 1 or a 2, I just combine these two categories of events. Why don't you figure out for me, so pause this video, figure out the probability of rolling an even number. Well, if I want to roll an even number, that's saying I roll a 2 or a 4 or a 6. So again, that's all of these and all of these and all of these put together. So that's 1/6 plus 1/6 plus 1/6 of the time, or half the time. So all I had to do was add up the probabilities of the different events that I wanted to have happen, and that ends up to being the probability of one of those events happening. Now let me ask you a third question. What is the probability that you roll the dice and the number that comes up is even or less than 3, or possibly both? Why don't you pause the video and think about that too? Well, in this case, there's some overlapping probabilities. If I'm even, I'm a 2 or a 4 or a 6. If I'm less than 3, I'm a 2 or I'm a 1. So it's no longer okay to say I'm going to add up the probability that I'm even and the probability that I'm less than 3, because then I would be overcounting the number 2s. So this is what we mean by disjoint. If I want to say the probability of one of these collection of events happening is just the sum of the probabilities, like we've been doing before, the probability of 1 or 2 is the sum, probability of 1 plus probability of 2. If I want to do that nice simple calculation, I need to make sure that I'm not accidentally overcounting. I need to make sure that no event can fall into both categories. And an event can fall into the category both even and less than 3 if that event is rolling the number 2. So just looking at our diagram, what proportion of these numbers are even or less than 3? Well, it's the 1s, the 2s, the 4s, and the 6s. So this is the probability of rolling a 1 or rolling a 2 or rolling a 4 or rolling a 6. These are disjoint events. If you roll a 1, you don't roll a 2, 4, or a 6. If you roll a 2, you don't roll a 1, 4, or a 6. And this is different from even and less than 3 because it's possible to be both. So when you want to calculate the probability of disjoint events happening, it's quite easy. You just add up the probabilities of the individual events, as we did here. If your events are not disjoint, if there's some overlap, then you need to find a different way of describing them. If you can find a way of describing them that really breaks them up into events that have no overlap, you really break them up into categories where only one category can occur at a time, then you have disjoint events and you can just add.